Hello and welcome back. Today we'll be doing question 5 from the 2021 math paper. This is a question for all applicants. Question 5. A triangular triple is a triple of positive integers a, b, c, such that we can construct a triangle with sides of length a, b, and c. This means that the sum of any two of the numbers is strictly greater than the third. So if a is less than or equal to b is less than or equal to c, then it is equivalent to requiring a plus b is greater than c. For example, 333 and 453 are triangular triples, but 132 and 336 are not. For any positive integer p, we define f of p to be the number of triangular triples such that the perimeter a plus b plus c is equal to p. Triples with the same numbers but in a different order are counted as being distinct. So f of 12 is equal to 10 because there are 10 triangular triples with perimeter 12 shown below. 345, 354, 435, 453, 534, 543, 255, 525, 552, and 444. Part 1. Write down the values of f of 3, f of 4, f of 5, and f of 6. Part 2. If ABC is a triangular triple, show that a plus 1, b plus 1, c plus 1 is also a triangular triple. Part 3. If xyz is a triangular triple with x plus y plus z equal to an even number greater than or equal to 6, show that each of xyz is at least 2 and that x minus 1, y minus 1, z minus 1 is also a triangular triple. Part 4. Using the previous two parts, prove that for any positive integer k greater than or equal to 3, f of 2k minus 3 is equal to f of 2k. Part 5. We will now consider the case where p greater than or equal to 6 is even, and we will write p is equal to 2s. Part A. Show that in this case ABC is a triangular triple with a plus b plus c equals p if and only if each of a, b, c is strictly smaller than s. Part B. For any a such that 2 is less than or equal to a is less than or equal to s minus 1, show that the number of possible values of b such that a, b, p take b take a is a triangular triple is a minus 1. Hence, find an expression for f of p for any even p greater than or equal to 6. Part 6. Find f of 21. Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with part 1. For part 1, we're just going to count all of the possible triangular triples, starting with 1, 1, and then the remaining number. For f of 3, there is only one possible triangular triple, that is just 1, 1, 1. For f of 4, we'll look at 1, 1, 2, realise that this is not a triangular triple because 1 plus 1 is equal to 2, not greater than 2, and we'll also realise that we can't actually get any other set of numbers, because if we try 1, 2, we're going to end up with 1 at the end, and that's just a permutation of 1, 1, 2. For f of 5, we're going to try 1, 1, 3, which is not a triangular triple. Then we're going to try 1, 2, 2, and we're going to realise that we have 3 permutations of that, so f of 5 is equal to 3. For f of 6, we'll start with 1, 1, 4, which does not give a triangle, 1, 2, 3, which does not give a triangle, and then we're going to try 2, 2, 2, which does give a triangle. Therefore, f of 6 is equal to 1. Now let's move on to part 2. Without loss of generality, we'll say that a plus b is greater than c, and a is less than or equal to b, and is less than or equal to c. Since we have a plus b is greater than c, and 2 also greater than 1, we have that a plus 1 plus b plus 1 is equal to a plus b plus 2, and this is greater than c plus 1. Therefore, a plus 1, b plus 1, c plus 1 is also a triangular triple. Now we'll look at part 3. Again, without loss of generality, we will assume the same conditions as part 2, and then we're going to consider the first case where x is equal to 1. If x is equal to 1, then we're going to need y is equal to z to form a triangle, because any difference between them is going to be 1 or greater. However, this would give x plus y plus z is odd, which goes against the assumption of this part. Therefore, we have that x, y, and z are all going to be greater than or equal to 2. We also have x minus 1 plus y minus 1 is equal to x plus y take away 2, and that is greater than z minus 2. Therefore, it's going to be greater than or equal to z minus 1. However, we can't actually achieve inequality, since that would give x plus y take away z is equal to 1, and therefore x plus y plus z is equal to 2z plus 1, and that's an odd number, which is not allowed. Therefore, we have that x minus 1, y minus 1, z minus 1 is also a triangular triple. Now, we'll move on to part 4. Firstly, part 2 gives us that a plus 1 plus b plus 1 plus c plus 1 is equal to 2k is a triangular triple if a plus b plus c is equal to 2k minus 3 is, and part 3 implies the same relationship but in reverse. Therefore, these two forms are in a one-to-one relationship, and this directly leads to f of 2k minus 3 is equal to f of 2k, as required. Now, we'll move on to part 5. Firstly, for part A, without loss of generality, we will assume A is less than or equal to B is less than or equal to C. Now, we'll see that if C is greater than or equal to S, which is equal to P over 2, then A plus B will necessarily be less than or equal to S, and therefore it is not going to be greater than C. For part B, we'll set C as equal to 2S take away A take away B, thus defining C in terms of A and B and S, and we'll also keep the condition that C must be less than or equal to S minus 1. Combining these two conditions gives us 2S take away A take away B is less than or equal to S minus 1, and therefore B is greater than or equal to S plus 1 take away A. However, B is subject to the same conditions as C, and therefore we also have B is less than or equal to S minus 1. Taking these together gives a total of S minus 1 take away S plus 1 take A plus 1 possible values of B, leading to A minus 1 values of B. Therefore, f of P is going to be equal to the sum from 2 to S minus 1 of A minus 1, and this is equal to the sum from 1 to S minus 2 of A, and this is going to be equal to S minus 2, S minus 1, all over 2. Finally, we'll move on to part 6. Here we have f of 21, which we can write as f of 24 take away 3. This means we only have to calculate the f of 24, which is equal to 11 times 10 all over 2, and this is equal to 55. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.